Okay, comparing and ordering fractions and decimals. One thing we've been working on is converting fractions to decimals. Fractions and decimals are the same in that both are fraction, part over total. A decimal is also a part of a whole number. And in decimals are place value. We have tenths, hundredths, thousandths, and we can keep going from there, but these are the three that we commonly will see this year. So when I'm looking at fractions and trying to make them into decimals, I need to look at my denominator. For me to change this to a decimal, the denominator needs to sound like one of our place values in the decimals. It needs to either say, sound like a tenth, a hundredth, a thousandth, and so on. We've got to have the denominator the same. We cannot just put a decimal in front of the 7 and call it a decimal, because I would read that as 7/8. And if I put a decimal in front of it, I would have to read it 7/10. Well, my fraction and my decimal must sound identical. So when we talked about the eighths with our flip book, the one you're supposed to be memorizing, the reason why we just want to memorize the eighths is because the eighths, to be converted to a decimal, we have to go all the way to the thousands place. So unless you know that 8 times 125 is 1,000, then it may take you a little while to get there, and we want to make this as quick as possible for you so you can just convert them and then move on. So with the bottom number being times 125 and the top number being times 125, that would make my top number 875. So 7/8, I can find the equivalent in 875 thousandths. Well, now I have a denominator that sounds like one of our place value in our decimals, thousandths. So now all I have to do is think about your decimal place value. We just wrote it up top. This is tenths, and I'm going to shortcut it, hundredths, and thousandths. Well, I just have to put my 875, because I read it, 875, and then I read the decimal place that the last digit is in, 875 thousandths. So now my fraction and my decimal sound identical. That allows me to now change, to compare it with the decimal that they gave me over here. Now, the first thing that we do with decimals, of course, is make them look the same, meaning make sure that you're adding zeros so that we end up with the same number of place values. So I was at tenths, but I'm going to go ahead and add zeros so that both of them are in the thousandths. Now I can just look at it, and I can always add a zero here as well. Now I can just look at it as 875 or 900. Which one is bigger? Well, my 9/10ths or 900 thousandths would be bigger than 875 thousandths. Okay, so let's try another one. Which of these is bigger? Okay, so I have 2/5, or I have 5/10. This is my tenths place. I can't see the decimal. So I need to convert 2/5 to a decimal and then compare them. Well, 2/5 is a little bit easier than our eighths, because if we start out with 2/5, again, I check my denominator is fifths. I go back to my decimal place value. I don't have a fifths place. I have to get to either a tenth, hundredth, or a thousandth. Well, I know 5, I can get to 10 very easily. 5 times 2, is 10. 2 times 2 is 4. Now my fraction is 4/10. I know that now sounds like a decimal place value. Now I can just put it into the tenths place, and my fraction 4/10 and my decimal 4/10 sounds identical. Now I can compare it to 5/10. Okay, let me rewrite this so you don't think that's circled for my answer. 4/10, 5/10. Well, they asked for bigger. So which one is bigger, 4/10 or 5/10? The bigger one is 5/10 because 5 is bigger than 4. Okay, let's have you try one. Get this out of your way. Go ahead and pause the video and try it, and then come back and check with me. Okay, so you should have tried this one on your own. We have 5/8 or 6/10. Again, I need to convert to a decimal. Well, 5/8, there's that 8 again. 5/8, those are going to be those that I memorize. So I already know 5/8 and its conversion, because I don't want to have to get to 1,000. So 5/8 is the same if I were to multiply by 125, it would be 625 thousandths as a fraction. And then I can easily put that into a decimal, 625, and then I read the place value, thousandths. Now I'm going to rewrite my 6/10 and make it go to the same place value, thousandths, so that I'm looking at 625 thousandths or 600 thousandths. Now this one asks which one is smaller. Which one is smaller? That would be my 600 thousandths. As you go towards the bottom, I guess there was a question in the middle of this, what did you do? Really, our strategy is just converting from fraction to decimal on the ones that we just tried. On the bottom, it gets a little bit different. Still converting fractions and decimals. But notice my fractions are a little bit larger. So I'm looking at 9/60ths, and I'm thinking, okay, I obviously can't get to a tenth. 100th, no, that's not going to go evenly, because then that would be 120. I could go all the way to 1,000, but something that I noticed is I have a 9 and a 6. I know that both 9 and 6 is divisible by 3, so I'm going to start with dividing the numerator and denominator by 3 and actually reducing the fraction. 9 divided by 3 is 3. 60 divided by 3 is 20. Now, am I at a 10, 100, or 1,000? No, but my number is smaller and more manageable, because now I can see that this 20, even though it's not one of my decimal places, I know that 20 can get very easily to 100 just by multiplying by 5, and whatever I do to the bottom, I do to the top. So then I can get to 1500ths. Now it's sounding like a decimal. I'm just going to write 15 and make sure it's in the hundredths place. And then I've got my decimal here that they already started me with, and that's 25 hundredths. So I don't even need to add zeros. They already are in the same place value. So for this one, they're asking which sign do I put, greater than, less than, or equal to. Well, I know that 25 hundredths is greater than 15 hundredths. Okay, so let's have you try one. I'm going to scroll down to number 7. Why don't you pause the video, try it on your own, and then come back and check with me. Okay, so you should have paused it on your own, tried it, and now you're checking with me. We start again the same way. I've got a fraction, 15/40ths, and then a decimal. 15/40ths is what I'm going to change. I want them all decimals. So I'm looking at it, can I get to a 10 hundredth or 1,000? tenth, no. Hundredth, no. Thousandth, well, maybe, but instead of trying to go all the way up, I'm going to now try to go down. I'm looking at 15 and 40. I noticed that we have a 5 for 15 and a 0, and I'm thinking divisibility rules. Our divisibility rule says if our numbers end in a 5 or a 0, they are both divisible by 5. So that'll at least get me to a starting point to make it smaller. 15 divided by 5 is 3. 40 divided by 5 is 8. Okay, and now I still don't have a tenth, hundredth, or thousandth, but that's one of our benchmark fractions that we're supposed to know. We know that eighths goes to a thousandths, and so I know the conversion for 3/8 is 375 thousandths, and now I can write that easily as a decimal, 375, and that's thousandths. And I'm comparing the 375 to 35 hundredths. Well, I want it in the thousandths place, so I'm just going to add a 0 so that they look the same, meaning they're in the same place. They go to the same place value. Now again, they're just asking me to write the correct sign. Greater than, less than, or equal to. Well, 375 thousandths is going to be greater than 350 thousandths. And so there's a question under here that says, well, how that strategy changed from what we were doing before? Well, on this bottom part, we really had to reduce, and even in some instances, grow the fraction, make it bigger to even get to that spot where we can convert. But we have to be really careful with conversions, is that they sound like a place value in our decimals. We cannot just put a decimal place in front of a number and call it a decimal. On the back, we have 2 boxes, which are going to look gigantic on here because I've blown it up. Let's see. With these boxes, we have to be able to convert so that all are either fractions or decimals, and so we're going to convert them to decimals, all of them. And then we have to be able to make decisions on them based on, try to get it smaller, there we go, based on some characteristics, like are they all more than 1? Are they all less than 1? Is one set all bigger than the other? Or maybe they're going to ask you to put them in order, something like that. So the first thing we want to do is make them all look the same. We're going to convert them to decimals. I'm going to leave this one right here alone first, because 9 is one of those repeating fractions that we're going to have to look at. I'm going to go to the next decimal, and I just rewrite them up here so that I can add zeros if I need to. This one is already a decimal. Fraction is already in the hundredths, so I know that I can just put it in a decimal form. And the last one's already in a decimal, but the last one goes all the way to thousandths. So I'm going to go back and make all of them go to the thousandths place. So what I'm looking at as I analyze my numbers is I notice in the tenths place, I have all numbers that are high. They're more than 5. We've got 7, 9, 6, and 8. Well, those are getting close to a whole. They're getting closer to a whole than they are to nothing, to 0. So my 7/9, if I'm not sure what that is, I'm going to go back to my picture. If I had to draw a picture of 7/9, what would I draw? Well, I would draw a picture with 9 boxes. I hope that's 9. And then I would color in 3, 4, 5, 6, 7. Well, look at my number that's colored in right here. Is that going to be closer to a whole colored in, or is it going to be closer to nothing colored in? Well, that's going to be closer to a whole, so we can make a guess or a prediction that 7/9 is going to be somewhere along these numbers where we have a 7, 9, 6, 8 in the tens place. We know that it's reasonable to assume that the number in the tens place for 7/9 is going to be definitely higher than 5. On the bottom, we have, again, I'm going to just rewrite. This one's already done for us. 90 thousandths. So I just want to make sure that that gets in the right spot. 90 thousandths. That one's already done. 12th, I'm going to leave alone, same reason. And then 300th. So I want to just make sure that my 3 gets in the hundredths place. But I look back and I have a lot in the thousands, so I'm going to make sure that they all have that same place value and look the same. So now what I'm noticing, tens place again, they're all zeros. So now these guys have got to be smaller because here we have zeros. The set above has numbers that are higher than 5 closer to 1 whole, where this set on the bottom is 0. They're actually closer to 0 than they are a whole. And just making that guess with 1/12, not knowing what 1/12 is, think again, picture. If you have 12 boxes and I only color in 1, well, am I closer to not coloring in any and having 0, or closer to coloring in the whole thing and having 1 whole? Well, I only colored in 1, so I'm closer to 0. So it's reasonable to assume that the decimal for 1/12 will probably also have a 0 in the tens place. Maybe a 1, probably not. And so we can still make a prediction about the different sets and what they mean. There are questions about that that you can answer. The last thing that I wanted to just go over is when you have a chart and you have, again, a mixture of fraction decimal, that you're just going to convert them so that they are all decimals, so that you can easily compare them. So for example, Mary is 38.5 inches. Well, 38 is our whole number, put that in front of the decimal. I know a half is 0.5 or 0.50 or 0.500, meaning 5/10, 50 hundredths, 500 thousandths. Mark is already done. Marley is in a fraction. I'm going to change that. It's a 37 whole. And then 3/4, I'm thinking quarters. That would be 3/4 would be 75 hundredths. Matthew's already done, so I'm just going to rewrite. And Mac, whole number is 37, 5/8. 5/8 is one of those benchmarks that I just need to know and memorize. That's 625 thousandths. So then looking back up, I'm noticing I need to have all my numbers to the thousandths place so that I can order them. And of course, when I order them, I'm going to start with the whole numbers and order them just like I normally would. And if I have to, I go to the decimal place. So for example, this is shortest to tallest, so smallest. Well, I know 37 and 37 are smaller than the 38. So then I have to look at my decimal. I have a 37 and 7/10, a 37 and 6/10. Well, I know 37 and 6/10 is smaller, so Mac must be the shortest out of all of them. And so I would start with Mac, and then I'm going to cross it out and get rid of it so I don't accidentally use it again. Then there's only one other 37. That's going to be Marley. That's number 2, and get rid of that one. And then go into our 38s and check your decimals. 38 and 1/10 is the next smallest. So that's Matthew. And cross it out. And then 38 and 4/10 is next. So Mark is next. And cross it out, and we're left with 38 and 5/10. And I just want to look at it and make sure I didn't mess up. And that is Mary.